Hello, let's take a look at the pre-final for trimester 2. Number 1 says find 2ab times the quantity 2ab squared plus a cubed minus 5b. What we need to do here is we need to use the distributive property and distribute 2ab to each of the three terms in the following trinomial. So 2ab times 2ab squared is 4a squared b cubed plus 2a to the fourth b minus 10ab squared. Again, when you multiply exponents with the same base, you are really just adding the exponents. So this final answer here would be, get my highlighter, would be C, 4a squared b cubed plus 2a to the fourth b minus 10ab squared. Let's take a look at number 2. Which binomial is a factor of 3bc plus 15c minus 2b minus 10? So this has 4 terms here, so we need to use factor by grouping. So what I'm going to do is regroup if necessary or rearrange if necessary the terms, and I'm actually just going to leave them as they are because I know with the 3bc and 15c I can factor out a 3c. So here I would factor out a 3c, then undistribute, and get b plus 5. Now within the negative 2b minus 10, I'm going to factor out a negative 2, and then get b plus 5, and that's great to see two factors that are alike, and that's what we want to see. So now when we rewrite our answer, we put the first two terms that we took out as a GCF together and get 3c minus 2 times the quantity b plus 5. So now if we look at our following answer choices, which of the following is a factor? Well, this would be letter B, 3c minus 2. Number 3, write a direct variation equation that relates x and y if y equals 11 when x equals negative 6. So if you can recall, direct variation is y equals kx. So we need to figure out what our constant, or k, is. So I'm going to substitute in 11 for y and negative 6 for x. So k times negative 6, and solve for k. So I'm going to divide by negative 6. So k equals negative 11 sixths. So if I rewrite that into a direct variation equation, I get y equals negative 11 sixths x, which would be, here's our answer, would be letter A. Number 4, simplify. 3 square roots of 6 times 5 square roots of 2. So if you recall, when you are trying to multiply radical expressions, I can multiply what's outside the radical together and what's inside the radical together. So 3 times 5 is 15, and then square root 6 times square root 2 is square root 12. However, that isn't the simplest form because I can continue to break down 12. So don't pick letter C. We can break 12 down into the square root of 4 times the square root of 3. Out comes a 2. So 15 times 2 is 30. Square roots of 3 would be the fully simplified answer here for number 4, which would be letter D. Number 5, simplify. The square root of 7 minus the square root of 10 times the quantity square root of 5 plus square root of 14. So here I see essentially two binomials that I need to FOIL or use the box method. I'm just going to FOIL here, and I have square root of 7 times square root of 5, which is the square root of 35. Now square root of 7 times the square root of 14, which is the square root of 98. And negative square roots of 10 times square roots of 5 is minus square root of 50. And negative 10 times the square root of positive 14, which is negative square roots of 140. But now I need to continue to break down each of those radicals. So let's see if we can break down square root of 35. The only factors that go into 35 are 5 and 7, which don't get us anywhere because those aren't perfect squares. So I'll just write down the square root of 35, because that's what it essentially stays the same. Now let's look at 98. 98 breaks down into the square root of 2 and the square root of 49. Out comes a 7, so I get plus 7 square roots of 2. Now let's break down 50. 50 breaks down into the square root of 2 and 25. So 2 and 25. And out would come a 5. So I get minus 5 square roots of 2. So we see a like radicand already. And last but not least, square root of 140 breaks down into 4 and 35. And out of the 4 comes a 2. So minus 2 square roots of 35. So now if I look at any like terms here, or like radicands, which is like terms, the square root of 35 minus 2 square roots of 35. And then I also see here that I have 7 square roots of 2 minus 5 square roots of 2. So if I put together those like radicands, square root of 35 minus 2 square roots of 35 is actually negative square root 35. And 7 square roots of 2 minus 5 square roots of 2 is 2 square roots of 2. So I would find that answer to be letter C, 2 square roots of 2 minus square root of 35. Number 6, determine which side measures form a right triangle. So this is going to be found by using the Pythagorean theorem. A squared plus b squared equals c squared. So if I go through and test those out, 4 squared, which is 16, plus 7 squared, which is 49, gives us 65, which is not 8 squared. So A would not work. B, 9 squared is 81, plus 12 squared, which is 144, is 225, and 15 squared is 225. So we actually know B will work out, so that will be an answer that works. But let's just check the other ones just to be sure. 3 squared is 9. 9 plus 7 squared, 7 squared is 49, equals 52, which is not what 9 squared is, 81. And then letter D, 10 squared is 100, plus 15 squared is 225, equals 325, which is not 20 squared, which is 400. So again, B works out, and we use the Pythagorean theorem to find this answer. Number 7, find the quantity of negative 3a squared minus r squared. So let's look here what we have to do. This really means I have negative 3a squared minus r times negative 3a squared minus r. So what I want to do here is I want to go ahead and FOIL or use the box method. I'll go ahead and I'll FOIL. So negative 3a squared times negative 3a squared is positive 9a to the 4th. Negative 3a squared times negative r is plus 3a squared r. And then again, plus 3a squared r plus r squared. So let's look here. If I combine some like terms, I get 9a to the 4th plus 6a squared r plus r squared for my final answer, which would here on our answer, all of our answers would be letter B for number 7. Number 8, solve x times the quantity x minus 5 plus 7 equals x times x plus 2 plus 14. So here what I need to do is I need to distribute this x right here and get x squared minus 5x plus 7 equals distribute x squared plus 2x plus 14. Now I want to look at isolating my x squared and x terms. So if I subtract x squared to move that to the other side, those will actually cancel out. And if I also subtract 2x here, bring it to the other side, I get negative 7x, and at the same time if I subtract 7 equals 7, divide by negative 7, and I get negative 1, which would be here, letter B. Let's take a look at number 9. Which equation corresponds to the graph shown? Well, what I would look here first is I would look at the y-intercepts and see what does the y-intercept look like it is about. It looks here like it's about negative 12. So right away, I can cross off letter C and letter D because those have a positive 12 or a negative 1 for a y-intercept. Then I would look at what's the vertex. So the vertex looks like it's about maybe 1/2 negative, a little over negative 12. So let's figure out what the vertex would be for each of A and B. So for A, I'd have opposite of B over 2A, which would be negative 7 over 2, which is negative 3.5. So it doesn't really look like the x-coordinate of the vertex, or the axis of symmetry, would be negative 3.5 here. And also the graph is scaled by 3's, so that will also play a difference too when we're looking at the y-intercept. If I look at part B, or question B is axis of symmetry, or vertex, I would do opposite of B over 2 times A, which is 1 over 2 times 1, which is 1/2. And so it does look like it's about, positive 1/2. So I could even plug that in and find the y-coordinate. But if I'm timed and this is the final, then, I would just obviously go with letter B here. And B would be the right answer. Number 10, find the equation of the axis of symmetry and the coordinates of the vertex of the graph of y equals 2x squared minus 12x plus 6. So let's go ahead and find the axis of symmetry, which would be opposite of B over 2 times A. So that's 12 over 2 times 2, which is 12 over 4, which is 3. So right away, I can cross out A and B, because those are negative 3. Now let's plug in the x-coordinate and solve for the y-coordinate. So 2 times 3 squared minus 12 times 3 plus 6. So 3 cubed is 9. 9 times 2 then is 18. Minus 12 times 3 is 36, plus 6. And that comes out to be negative 12. So our answer here would be letter C, which would have the axis of symmetry at x equals 3, and then my vertex at 3, comma, negative 12. Number 11, find the coordinates of the vertex of the graph y equals negative 2x squared minus 8. Well, here we know it's a negative, so it's going to open downward, so it will have a maximum. So that means I can cross out letter A right away, but now let's find the vertex coordinates. So opposite of B would be opposite of 0, which doesn't exist. So 0 would be the x-coordinate of the vertex, so I would cross out B. And then if I would plug in 0, negative 2 times 0 squared will be 0, minus 8 will be negative 8. So here my coordinates of my vertex would be 0, comma, negative 8, and that are in this equation, the graph of this equation would have a maximum. Number 12, determine the roots of the quadratic equation y equals x squared minus 13x minus 30. So for this problem, I actually need to factor and then set my factors equal to 0 and solve. So I'm going to use the diamond method, and I'm going to say factors of negative 30, that would add together give me negative 13, and that would be negative 15 and positive 2. So I would set those factors equal to 0. And I would get x equals positive 15 and x equals negative 2. So in ordered pair form, this would actually be answer B, 15, comma 0 and negative 2, comma 0. Number 13, how is the graph of g of x equals the quantity x minus 3 squared minus 5 related to the graph of f of x equals x squared? Well, we have to recall here our transformations of quadratics. So this quantity x minus 3 squared actually goes right 3 units. And then this negative 5 here goes down 5 units. That's really the only transformations that we see here from the parent graph of x squared. So this would be answer letter C, translated right 3 and down 5. Number 14, which equation is equivalent to 2x squared minus 24x minus 14 equals 0? Hint, complete the square. So if you can look at our 4 answer choices, those actually require us to complete the square and not actually solve for x, but get use the steps of completing the square to get so far as to where we then could solve it. But here they don't necessarily want us to. So let's look at the process of completing the square. I have 2x squared minus 24x minus 14 equals 0. First thing I'm going to do is divide everything by 2. So I get x squared minus 12x minus 7 equals 0. I'm going to move the 7 over because I don't have a perfect square trinomial. So I'm going to replace it with what should be there. So if I add 7 to both sides. Now, how do I find out what c is? Well, I take half of b and I square it. So half of negative 12 squared. Half of negative 12 is negative 6. Negative 6 squared is 36. So I will have x squared minus 12x plus 36 equals 7 plus 36. And then here I want to factor my left-hand side. So what I get when I factor my left-hand side is I get the quantity x minus 6 squared equals, now 7 plus 36 is 43, and that's actually all the further I need to go within the steps of completing the square because I see my answer. Here it's answer letter A, or excuse me, answer letter D, because the quantity x minus 6 squared equals 43. I don't have to go any further, but we did need to use the steps of completing the square in order to find our answer here. Number 15, use the quadratic formula to solve. X squared plus 8x equals 2. Round to the nearest tenth if necessary. So I'm first going to make sure I remember what the quadratic formula is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to move the 2 over, so here a would be 1, b would be 8, and c would be negative 2. So this will be x equals negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 2 all over 2 times 1. So let's simplify what's in the radical. And when I simplify what's under the radical, I get x equals negative 8 plus or minus the square root of 72 all over 2. So now on my calculator, I will type in negative 8 plus the square root of 72, hit enter, and then divide by 2. And when I do that, I get, rounded to the nearest tenth, 0.2. Now on my calculator, I will type in negative 8 plus or minus the square root of 72, hit enter, and divide by 2. And I get negative 8.2. So those are my two solutions. So if I look at the choice of answers, my answer here would be letter A. Number 16, determine the number of real roots of 7x squared minus 18x plus 12 equals 0. So this is where I want to use the discriminant and use b squared minus 4ac. So here, b is negative 18 squared minus 4 times a times c. And when I simplify that, I get negative 12. So since my answer is negative, that tells me I have no real solutions. If that came out to be positive, I would have had 2, and if it came out to be exactly 0, I would have had 1 solution. But here, since my answer is a negative, I have no solution. Number 17, which is the equation for the nth term of the geometric sequence of negative 4, 8, negative 16, and so on? So I can tell that the common ratio here is times by negative 2. So if I look at my following choices here, and I'll zoom in, I see a lot of different recursive formulas. So if you can recall with the recursive formula for geometric sequence, it is first term times the common ratio to the n minus 1 power. So here, as I look at my choices, I can see that letter C has my first term of negative 4, my common ratio of negative 2, then to the n minus 1 power. I know we also learned another formula for this. The only other choice that this could be, if I was looking at not the recursive formula, just a generic sequence formula, would be letter D. A sub n equals, and this would be your 0 term times the common ratio to the power of n, but that doesn't work because my common ratio isn't 4, right? My common ratio is negative 2. And my first term wouldn't even be negative 2, it would be positive 2. So that doesn't work. And letter A wouldn't work because my first term isn't negative 2. And B wouldn't work because the common ratio is positive 2, or negative 2, not positive 2. So again, my answer would be letter C here. Number 18, which equation represents exponential growth? So as I look at all the choices here, I want to look at which one will for surely be an exponential equation, and then what will represent the growth. So as I look at letter A, A, I have 0.84. Well, I do have exponential because it's to the power of x, but the 0.84, that's less than 1. So it tells me that that must have been simplified by taking 1 minus the rate and get a number less than 1. So that can't be exponential growth. That's actually decay because 0.84 is less than 1. B is a linear equation, so that's not even exponential. C is to the third power, that's cubic, so that's not exponential. And letter D is y equals 5 times 1.06 to the power of x. That is exponential, and 1.06 is greater than 1, so that tells me that that is exponential growth. Number 19, a weightlifter can deadlift 315 pounds. She can increase the weight, W of x, that she can lift according to the function W of x equals 315 times 1.05 to the power of x, where x represents the number of training cycles completed. How much will she deadlift after 4 training cycles? Well, this one's just simple enough. I just want to type in or plug in 4 in for x and then solve. So here I'll type that into my calculator and I will get my answer. I get about 382.88, so 382.9, which would then be closest to 383 for what I would round up for 383 pounds. Number 20, a city's population is about 954,000 and is decreasing at an annual rate of 0.1%. Predict the population of the city in 50 years. So this is an example of exponential decay, where I'm going to write my initial amount times the quantity 1 minus my rate. And here I have to move the decimal over 2 places. So 0.001 all to the power of 50. And when I type that in my calculator, I get 907,450.1693. So I'm going to round this then to the nearest person, which would be 907,450 people. Number 21, a certain fast-growing bacteria increases 6% per minute. If there are 100 bacteria now, about how many will there be 12 minutes later? So this is an example of exponential growth, so I'm going to write my initial amount of 100 bacteria times the quantity 1 plus my rate, and again I have to move my decimal over 2 places to the left, so I get 0.06 for my rate, all to the power of 12. Now I'm going to figure out what that is. I'm going to type that into my calculator right now, and I get about 201.2 bacteria, which then I will just round to 201. Answer is letter B. Number 22, look for a pattern in the table of values to determine which model best describes that data. So as I look at my table, I can see that the x values are all increasing by 1 and the y values are being multiplied by 7. So I know that this example will have to be exponential. If it were linear, I would be adding or subtracting a certain amount. Quadratic would have common second differences, and exponential has a common factor, which is what we see here of multiplying by 7. 23. Which function best models the data in question number 22? So we know it's exponential, so therefore I can cancel out letter C. Right? No, it's not going to be C, and no, it's not going to be A because that would be linear, so we're down to letters B and D. So again, with exponential, we have y equals a times b to the x, where a is your y-intercept and b is your common ratio. So here, if we look at the table, the y-intercept is 1, so that would be y equals 1 times, and then my common ratio is 7 to the power of x, and you don't even necessarily need that 1 to be written in, and but it's like a silent 1. So that actually would be answer letter B, y equals 7 to the power of x. 24. How does the graph of g of x equals negative 3/4 times 1/2 to the x plus 5 power compare to the parent graph of f of x equals 1/2 to the power of x? So again, this is transformations, but now of exponentials. So this negative here is a reflection over the x-axis. The 3/4 is a compress. 1/2 is just the base, and that's comparing to the parent function base, so that's okay. And then x plus 5 goes to the left 5. So out of my answers here that I see, letter A incorporates all the transformations that are happening to this graph. Compress, reflect over the x-axis, and left 5 units. Number 25, identify the asymptotes of the rational function y equals 4 over x minus 1. So to get the vertical asymptote, I am going to set my denominator equal to 0. So that would be x equals 0, and so that one's really easy. It just is 0. And then for the horizontal asymptote, I set y equal to whatever c is. So here, that's negative 1, so y would equal negative 1. So my answer here would be letter B, x equals 0, y equals negative 1. Number 26, solve the square root of 3x plus 1 plus 3 equals 7. So steps to solve radical equations. First rule with that, or the first step, is to isolate the radical. So I'm going to subtract 3 from both sides and get the square root of 3x plus 1 equals 4. Now that the radical is isolated, I am going to square both sides and get 3x plus 1 equals 16. And now I'm just going to isolate my variable x. So I'll subtract 1, get 3x equals 15, divide by 3, and I get x equals 5. And I only have one solution here, but it's always good to check and make sure it's not extraneous. So if I plug that back in, I would get 3 times 5 plus 1, the square root of that, which is 15, plus 1, which is square root of 16, plus 3 must equal 7. Square root of 16 is 4. 4 plus 3 does indeed equal 7. So my final answer would be letter D, 5. Number 27, solve the square root of 5x plus 39 equals x plus 3. So another radical equation question. The first step is isolate the radical, and it is isolated. So step 2 is to square both sides. So then I'm just left with 5x plus 39. But now on my right-hand side, I must FOIL x plus 3 times x plus 3. And when I do that, I get x squared plus 6x plus 9. And now I want to get everything to one side so I can eventually try and factor and solve for x. So I'll subtract 5x and subtract 39. And I get 0 equals x squared plus x minus 30. So now I want to find factors of negative 30 that when added together give me positive 1, which would be 6 and negative 5. So my two solutions would be negative 6 and positive 5. So now I'll want to try and test those out to make sure one is not extraneous. And so the first one I'll plug in will be negative 6. So 5 times negative 6 plus 39 equals negative 6 plus 3. Well, 5 times negative 6 is negative 30. Negative 30 plus 39 is 9. So is the square root of 9 equal to negative 3? It is not, because the square root of numbers for radical equations can only equal positive answers. So I would cancel out. And now if I check the other one, the square root of 5 times 5 plus 39 had better equal 5 plus 3. So 5 times 5 is 25. 25 plus 39 is 64. And is square root of 64 equal to 8? You bet. So my answer here would be 5, would be letter C. Number 28, if y varies inversely as x and y equals 0.8 when x equals 1.8, find y when x equals 4.8. So here we have inverse variation, which means xy equals k. So in our first example, we have 0.8 times 1.8, which equals 1.44. So I have xy equals 1.44. So now, if I know that 1.44 must equal 4.8 times y, now I just have to solve for y and divide by 4.8. So 1.44 divided by 4.8 is 0.3, which here for us would be letter B. Number 29 says state the excluded values of x squared minus 3x minus 28 over x squared plus 3x minus 4. So to find the excluded values, I need to set my denominator equal to 0. So I need to factor and find factors of negative 4. That would netted together give me 3, which here would be positive 4 and negative 1. So then I would set x plus 4 equal to 0 and get negative 4, and set x minus 1 equal to 0 and get positive 1. So my two answers would be negative 4 and positive 1, which here would be letter D. Number 30, simplify x squared minus 8x plus 16 over x squared minus 16. So what I'm going to do here is factor the numerator and find factors of 16. That when added together give me negative 8, which are negative 4 and negative 4. So my numerator I can simplify to x minus 4 times x minus 4 over, and actually here the denominator factors into x minus 4 and x plus 4, so I'll rewrite that up here, x minus 4 and x plus 4. So now if I want to simplify, I see that x minus 4's cancel out, so I'm left with x minus 4 over x plus 4, which here would be letter C. Number 31, find 3a squared b divided by 6b squared c cubed times 12bc squared over 15a. So I want to look at cross products and see what I can cancel out here. So I'm going to take out, with the 3 and the 5, a 3, or 3 and the 15, excuse me, take out a 3. I'm also going to take away an a. With the 6b squared c cubed and 12bc squared, I'm going to take out a 6, take out a b, and take out two c's. So what I'm left with is ab over bc times 2 over 5. And I'm going to continue to take out a b here and here. So now I have 8 times 2, which is 2a, over c times 5, which is 5c, which would be here letter C. Number 32, find x squared plus 4x plus 4 over x times 9x over x squared minus 4. And let's try and simplify this by factoring the first rational expression of x squared plus 4x plus 4 into x plus 2 times x plus 2 all over x times 9x over, now let's factor x squared minus 4 into x minus 2 times x plus 2. And now I'm going to cancel out some some similar terms here, cross products, and I'm going to take away an x and an x here. So what I end up getting is 9 times the quantity x plus 2 all over x minus 2, which here for us would be letter A. 33 says write an inverse variation equation that relates x and y when x equals 12 and y equals negative 13. So again, if you recall with inverse variation, xy equals k. So now I know that I have 12 times negative 13, and 12 times negative 13 equals negative 156. So my equation would just be xy equals negative 156. So my answer here for 33 would be letter B. Number 34 says find x squared plus 3x minus 10 over x squared plus 6x plus 8 divided by x minus 2 over x squared plus 2x. So before we flip the second fraction and multiply, let's go ahead and simplify our first rational expression. So if I factor the numerator of x squared plus 3x minus 10, I would use the diamond method, and I will get x plus 5 times x minus 2 all over, this would be x plus 4 times x plus 2, and then multiply by take out a x and then get x plus 2 if I factor the x squared plus 2x all over x minus 2. Now I'm going to look at canceling cross products. So the x minus 2's cancel, x plus 2's cancel, and I'm left with x times x plus 5 all over x plus 4, which here for us would be letter A. Number 35, find 10x cubed plus 15x squared minus 8x minus 12 divided by 2x plus 3. So here I'm actually going to have to use long division. So I'm going to slide right over here. I'm going to use long division. So I have 2x plus 3, and then I have 10x cubed plus 15x squared minus 8x minus 12. And I have all the degrees showing, so I'm okay here. So now I'll say 2x goes into 10x cubed, 5x squared times, subtract, so 2x times 5x squared is 10x cubed. 3 times 5x squared is plus 15x squared. So now if I subtract, these actually both cancel out. So I need to bring down the negative 8x and the negative 12. And now I'll ask myself, 2x goes into negative 8x, negative 4 times. And then 2x times negative 4 is negative 8x. 3 times negative 4 is negative 12. Subtract, get 0, so I don't have a remainder. So my answer is just 5x squared minus 4, which here would be answer letter B. Thanks for listening. I hope that this video helped with you in solving all the problems here for your pre-final for trimester 2. Feel free to rewatch any part of this video again to help you understand the problems even a little bit better. Have a great day. Bye-bye.